Welcome to the first part of the course where we'll walk through the modeling process in Revit. To start, this is the model we'll be working with throughout the course. In this initial section, we'll specifically focus on modeling this module within the overall project. However, you'll also have access to the complete project file for the next sections of the course, where we'll be working with Rodzer and Power BI. For this first part, which focuses on the modeling process, we'll work with a file that has a section missing. This is the part we'll use as the basis for the video. You can access this file along with the blueprint files we'll be using in this tutorial in the video description. There, you'll find everything you need to follow along step by step. Before we begin, here's a quick overview of how this video is structured. We'll start by modeling the foundation. That includes footings, columns, and foundation beams. Then we'll move on to the first floor, where we'll model the columns and the slab. You can see the slab from below in the model. Next, we'll model the walls and finishes, such as the types of flooring we'll use, and we'll also cover the overhead beams. Finally, we'll finish by modeling the roof. As you can see, it's a sloped roof, so we'll go over how to model elements like this angled wall or this inclined beam to achieve the final sloped result. With that in mind, the first thing we need to do is go to the view where we'll begin modeling the foundation. That view is called Cole Foundation. In this view, we need to import the blueprint that contains the foundation elements. To do that, go to the Insert tab and use the Import CAD option. Click on that and browse your computer for the blueprint file we'll be using. For this first step, the file is called Foundation Blueprints Block A. Select it and check that the import settings are correct. The units should be in meters, the positioning should be manual, center, and make sure it's placed on the Cole foundation level. Once everything looks good, click Open. The plan will load and you can click anywhere to place it. As you'll notice, the block appears to be rotated, so we'll need to rotate it to align it correctly with the project axis. To do this, we'll use two tools: Rotate and then Move. First, select the plan, choose the Rotate tool, and define a central axis. We'll set it vertically, then rotate it 45 degrees to the left. You can either use your mouse or simply type in 45 and press Enter to rotate it automatically. Next, we'll move the plan using the Move tool. This will help us snap the plan to the correct grid location. For example, I'll select the midpoint of this modeled column and move it to align with this axis. To confirm alignment or make fine adjustments, switch to the 3D view and check if the plan is aligned with the other already modeled elements. From the top view, for instance, you might see that the foundation plan is slightly misaligned with the footing. To fix this, you can nudge it using your keyboard arrow keys. By moving it slightly to the right and upward, we can align the blueprint with the existing modeled elements. Once the plan is properly aligned, return to the working level, and you'll be ready to start modeling the elements. To model the footing, go to the Architecture tab and select the Component option. This will open a list of all the families loaded into the model. From that list, search for the footing family. Zoom into your blueprint to identify which type of footing is required. For example, in this location, the plan specifies footing type Z1. So select footing Z1 from the list. At first, it might seem like your cursor is ready to place the element, but the footing may not be visible in the current view. If you try placing it anyway, you'll likely get a warning saying that the element is not visible in this view. However, if you switch to the 3D view, you'll see that the footing is actually being placed. You might even see the one you already tried to model. To fix this, delete the misplaced element and adjust the view range of the level you're working on so you can model correctly in the plan view and confirm everything visually. To do that, go to the Properties panel on the left, look for the option that says View Range, and click Edit. Then set the following parameters. The top should remain the same level you're working on, but increase the offset so that it includes elements slightly above the cut plane. Now change the bottom to the level right below, which corresponds to the footing level, and give it an offset of -2. Do the same for the view depth. Set it to the footing level with an offset of -2. Then click OK. Now when you place the footing, you'll see that the cursor shows exactly where it's being modeled within the plan view. You might notice, though, that the footing appears vertically aligned and not rotated like your plan. To correct this, hover your mouse over one of the corners where you want to place the footing and press the spacebar. Pressing the spacebar rotates the element, so it aligns with the direction of the plan, making it easier to place. Now go ahead and place the footing. If it looks a bit misaligned with the plan, just click on it and use the arrow keys on your keyboard to nudge it into the correct position. Repeat this same process for each of the remaining footings. Be sure to check the type of footing required for each location. For example, in this case, the blueprint calls for footing type Z2. So again, go to Architecture, then Component, and within the family list, switch to Z2 before placing it. Once all the footings are placed, go to the 3D view to confirm that everything is properly modeled. Now that the footings are complete, we're ready to begin modeling the columns. To check which columns we need to model, we can look at the other modules that are already in the model. If we select one of the existing columns, we can see that its type is column C400 by 500. So let's go back to the floor plan where we're working. Go to the Structure tab, select Column, and look for that same column type, COLC 400 by 500, in the loaded families. Before placing the column, let's review the placement settings. By default, Revit is set to model the column with its base extending down to the footing level, which is below the level we're currently working on. But that's not what we want. We want the column to go upward from the current level to level 1. So we change the placement option from depth to height and set the top constraint to level 1. Once that's done, we're ready to place the column. As before, we can press the space bar to rotate it if needed. Place the column here and then repeat the same process for all the other columns, which, as you can see, are of the same type. Now that all the columns have been placed, let's switch to the 3D view to confirm everything is positioned correctly. And yes, here we can see that the columns are short columns that reach only up to level 1. Next, we're going to continue with the foundation beams. In the blueprint, we can check which type of beam is needed for each axis. For example, along this axis, the beams have dimensions of 0.3 by 0.4 meters. And along the other axis, the beams are 0.3 by 0.3 meters. To model them, go to the Structure tab and select Beam. In the list of available families, search for the beam types you need. We'll start with the VC1 beams, which are 0.3 by 0.3 meters. Select that type, and before placing them, make sure the placement level is set to level 1, so the beams are correctly positioned. Now begin modeling the beams from the center of one column to the center of the next. I've already modeled the beams along all the axes, making sure to use the 0.3 by 0.4 beams in the appropriate axes and the 0.3 by 0.3 beams in the others. We can now check in the 3D view to confirm that all the beams have been placed correctly. The final step in this foundation stage is to work with the shared parameter in the model called 4D Task ID. If we select any of the elements we've already modeled, we can see in the Properties panel that this parameter appears with a value. This parameter will allow us, later on when we integrate with the Rodzer platform, to link external information that doesn't exist directly in Revit. In this case, the 4D Task ID refers to a 4D simulation, where the time dimension is added to the project. Each value is assigned by group of elements. For example, this is a foundation beam, and all foundation beams share the same value. Here, it's 13. This allows us to later add additional information, such as construction start and end dates. Having a parameter that identifies elements by group also helps us include other types of data. Later in the course, we'll add a 5th dimension, which includes the costs associated with each project element. So now, the last thing we need to do is assign the appropriate 4D Task ID values to the elements we just modeled. The foundation beams will have a 4D Task ID of 13. And the isolated footings, meaning the footing together with the base section of the column, will have a 4D Task ID of 11. Let's go ahead and select the elements. For example, here I'll select all the foundation beams and assign them the 4D Task ID value of 13. Then I'll do the same for the footings. I'll select the footing along with its column base and assign them the 4D Task ID value of 11. With that, we've completed the foundation stage, and we're now ready to move on to modeling the first floor.